for the most part, we're talking x squared functions. And we've talked about these previously because with our shifting, we talked about these x squared graphs, some of the more basic ones, right? We've done x squared and then shifted it around. What does that look like? Well, it's the arch shape or the U-shape graph, and sketching in real quickly there. That's what it looks like. And then what we did with it previously, and we'll talk about that more in a second, but we shifted that around. But the other thing, well, let me go ahead and state here that the shape, I may have mentioned before, you may have heard before, but the shape of an x squared graph is called a parabola. Looks like parabola, but it's pronounced usually around these parts as parabola. And all x squared graphs will have that basic shape. Now, the other one of note that we should note is, of course, we have the other version of it. If I just do a simple little transformation there, what happens there? Well, that reflects it in the x-axis, but it makes the parabola upside down, doesn't it? And so, yeah, there's two basic shapes in the parabola. It's the parabola that opens up, and then we have the parabola opening down. Now, as far as the equation goes, let's go ahead and notice here, why does this one open up? Why does this one open down? Well, it's because of the minus, isn't it? If the x squared is a negative, you're going to have an opening down parabola. It doesn't matter, you know, this is a very simple equation, but even if we put a couple more terms on out there, if the x squared term is negative, it is going to be opening down. If the x squared is a positive, it will open up, and we'll say more about that in just a second. Okay, now, a couple other things. Let me draw another one. This one's been shifted a little bit, transformed, we might say. All right, let's say we've got 1, 2, 3 there. Maybe 1, 2. All right, so we're going to have this point here. Looks like it's 3, 3, 2 maybe. Okay. Yeah, a lot of these that we're going to see parabolas that are shifted off of the 0, 0 point there. Okay, but anyway, this point here, call it the turning point because, you know, in this case it's a low point. When it opens down, you got a high point. But that turning point, that's referred to as the vertex. And in general, we label the vertex, since the vertex is the point, a point, we give it an x and y coordinate, and usually the way they denote the vertex is hk. H is the x coordinate of the vertex, and k the y coordinate of the vertex. So in this case, it looks like the h is going to be 3, the k is 2, but that's not really my point here. It's just to tell you that in general, the vertex is labeled h, k, and all parabolas will have one of those, whether it's the low point or the high point, but every parabola has one. Now, what's the vertex on these? 0, 0, isn't it? 0, 0 is the vertex on both of those, but if they're shifted off of the origin there, we'll talk about that. Now, there's a couple other things we'll talk about, but one in particular here that can be helpful in graphing these. If I drew a line right down the middle of that, this graph is very symmetrical about that line. You see, it's a kind of a mirror image. If I draw a line right down the middle, it's very symmetrical. This piece is just a mirror image of that piece. So for that reason, this line through the middle is called the axis of symmetry. because what you have on one side, you'll have a mirror image on the other side. Symmetrical. All right, and how that can help you is, say we knew this point looks like 2, maybe 3. Well, if that point's at 2, 3, then there's a mirror image copy of it at, you know, the same distance over here, the same level here. So that would be at 4, 3. Same thing if I have a point here at 1, whatever it is, then I've got another point at 5 at the same level. So, yeah, there's those mirror image points, copies on the other side, equal distance away, like that. Okay? So that can, you find one point, then you can find the other point across from it very, very easily there. And there's a couple other things, but we'll save those for later. All right? Okay, well, since we've just gotten through shifting, let me start with, there's two forms of these quadratics that I wanted to mention. The first form Roman numeral 1, let's call it, is, I like to call it vertex form. The book likes standard form, okay? That's what they call this particular form, but here's one look at one in particular example of vertex form. F of x equals 2 times x minus 1 squared minus 3. I start with this one because we know some things about this one, don't we? What do we know about this? What can you tell me about? Because this is taking the x squared and transforming it, isn't it? What is something done here to the x squared graph by this form here? It's shifted it, hasn't it? It's shifted it because I've got the minus 1 on the inside, the minus 3 on the outside. This graph has been shifted. So what does that do? Shifts it 1 to the inside is to the right or left. Minus goes to the right. All right, so it's 1 right. And then the minus 3 on the outside makes it go, a minus 3 makes it go 3 down, yes. And so, yes, he's right, because that, what that'll do then is that not only shifts 1 point, let's put it right here. So here's our x squared graph, 0, 0, 1, 1, minus 1, 1, 2, 4. It's going to take, all these points. Dot that in a little bit. It's going to take that graph and shift it, among other things, 1 right and 3 down. Well, in particular, doesn't that shift that vertex to where? Shifts it to 1 to the right, down 3. So now isn't that the vertex? 1 down, 1 to the right, 3 down. Where's my vertex now? Well, it's at 1, negative 3. Hey, how about that? 1, negative 3. That's why I like to call this vertex form, because if you've got this form, you've got the vertex showing up right in the equation. 1, negative 3. Now, note there, the vertex is 1, positive 1, not negative 1, because it's 1 to the right. So it's kind of the opposite on that. Of course, the minus 3 is minus 3 there. But you've got the vertex right on the right on the equation. Okay? Now, here's some other things. What do you know, what happens based on previous observations with that 2? What's that going to cause the graph? We talked about a little. I don't know that we did just a whole lot with it, but we talked about it a little bit. The 2 in front causes it, in the case of a parabola, cause it to narrow up. It stretches it is the official word there, but it stretches it by a factor of 2. And so that's going to make this graph become narrower. So instead of this wide, it's going to become narrower here. That's one thing, so that makes it narrower. But even more in particular, we'll do some other things to get the rest of the points here, but what else we can note here is if I, what about up or down? Is this graph going to open up or is it going to open down? It's going to open up. Why? You're going to have a positive x squared because, I mean, you'd have to FOIL that out a little bit and multiply it by 2, but it's going to wind up being, isn't it? If I multiplied all that out, it's going to wind up being 2x squared, whatever the rest is, something x, something c, but the x squared is going to be a positive because of that number right there. Okay, so it's going to be narrower and it's going to open up. Narrower than the x squared graph and opening up. Okay. So it's a pretty handy form to have, vertex form. Now, to get the rest of the graph, like I said, we've got the vertex is right there, and we've got that it opens up, so it is going to be opening up. But to get, I like to have pretty accurate graphs here, so let's get some other points. And on a lot of graphs, other points are going to be like the intercepts. In this case, I'm just going to be interested in the y-intercept. The x-intercept's a little tricky to get, but we could do it. But let's see if we can get that y-intercept. How do I get the y-intercept? Always the same way. How do I get the y-intercept? Well, I set x to 0. And this is not the easiest of any y-intercept, but it's not too bad. If I just set x here to be 0, I have 2. That'll give me my y-intercept. 2 times that would be 0 minus 1 squared minus 3. And so that's going to be y equals 2, and that's going to be negative 1 in the parentheses squared minus 3. Now, please note, we do the squaring first. So that would be positive 1. Minus 3, 2 times positive 1 minus 3, which is going to be 2 minus 3, which is negative 1. So my y-intercept, I'm going to have a point 0, negative 1, aren't I? Which is right here. Okay? Now another quick point we can get from that is a point straight across from, because there's this axis of symmetry going through the vertex. So don't I have by the axis of symmetry there, don't I have a symmetrical point at that other side there, across from through the axis there? Yeah, so theirs is a nice, pretty accurate graph for 2x minus 1 squared minus 3. F of x equals. How about that? Okay? All right, so, and we just really used 3 points. We knew it was a parabola that opens up, so I knew that, and I knew my vertex, and I got that point and that point. That's enough to graph this thing. 3 points, you got it. All right? Okay, so here's, in general, how we write, so we got that one? Vertex form. So vertex form of a parabola in general looks like this. F of x equals a, we are going to call this letter in front a because, like from the quadratic formula, you got ax squared plus bx. That's the same thing as a is in that. So we'll put the a in general in front there, and then it'll be times x minus h squared plus k. And what's special about h and k? That's the vertex, okay? So this is, in general, this is a parabola with the vertex h comma k. And we can also say, with a there, if a if A is a positive greater than 0, then the parabola opens which way? If A is greater than 0, that's an A is positive, like 2 or 3, opens up. If A is less than 0, A is negative 2, negative 3, negative 1, whatever, it opens down. Okay? So just from sight there of the equation, in that form, you get that information. All right, so let's do another one of those. Yeah, let's go ahead and do the whole thing, graph and all that. Getting some various pieces of information. Negative 1/2 f of x equals negative 1/2 x plus 3 squared plus 5. Do you believe? Okay, negative 1/2 x plus 3 squared plus 5. Okay, well, is it a parabola? Yep, you got the x squared. Anytime you have an x squared graph, it's a parabola. All right, and so it's in vertex form, isn't it? Well, let's go ahead and talk about which way it opens. Which way is this one going to open? This one's going to open down, yeah. We've got A is negative 1/2, and if A is a negative, yeah, that parabola is going to open downward. What is the vertex? Well, if it's in this form, you got the vertex right here and right here, don't you? Now, in this case, unlike that one over there, or the first one, I've got a plus 3. What am I going to do there? Is it going to be negative 3? Yeah, it's going to be negative 3 because isn't the shift here going to be to the left 3? Yeah, so I just changed the sign. Just like here, I changed it. It's minus h there, it appears, so it's going to be h here. Well, here it's positive 3, so it's going to be a negative 3 for the h. The k doesn't change because that's going to move it up 5, so positive 5. See that? So you change, so to speak, signs there. Negative 3, 5. Okay, well, that's pretty good. Negative 3, 5. Right there. There's my vertex. And it's going to open down. So I could sketch it in roughly anyway right there. However, I will want you to get a couple more points, and we can get a couple more just by using the y-intercept again. What is the y-intercept here on this one? Oh, one other thing before I do that. Also, note here, I said it opens down because that's negative, but it's a 1/2 in front. Do you know what that also means? As far as narrower or wider? It's going to be wider, yeah. X squared like this, so it's going to be wider. Of course, it's going to be opening down, so instead of x squared, it's got 1/2, so it's going to be should be wider. Okay, but anyway, the y-intercept will help us with that. What is the y-intercept? Well, you set x to be 0. Negative 1/2 be 0 plus 3 squared plus 5. Okay, so that's y equals negative 1/2. That's just 3 squared plus 5. And again, remember on these you do the squared first, so that would be negative 1/2 times 9 plus 5, which is negative 9/2. That's 9 over 1 plus 5, which negative 9/2 is negative 4.5 plus 5, which is 0.5, isn't it? 0.5 is the y-intercept? I do believe so. Positive 0.5. Okay, so right there. All right, so that winds up being there. Well, here's my vertex, and by the axis of symmetry right down through there, isn't there a point this same distance on the other side at 0.5? I do believe so. And that would be Well, that's 3 away, so it'd be 3 away here. So it'd be negative 6 is the x value of that. With me on that? So there you go. Yeah, it's a wider thing. Okay. All right. So yeah, we can track. I don't. Let's go. Let's see. Yeah. Let's just on this one. Tell me. Tell me what you see there. Well, that's a parabola opening up, right? Positive A. And the what's the vertex? 7, 11? Positive 7 or negative 7? Positive 7, positive 11? Yes. I believe so, yeah. So this one, yeah, this one's going to open up. Vertex is going to be positive 7, positive 11. So that one, I mean, you can track these down anywhere. I mean, that one's pretty good ways out there. Positive 7, positive 11, and it's much narrower than the x squared graph because that's a positive 4. So, I mean, you're talking x squared here. That one's going to be really, really narrow. Another point we could talk about is, yeah, if that's 7, then I could look at this 6 point. If x is 6, that might be a little better than the y-intercept in this case. If you've got x is 6, then you'd have y equals 4 times 4 times 6 minus 7 squared plus 11. If you're wanting another point close by there, that would be what, 4 times 1 plus 11, because you're going to square a negative 1. Yeah, that's 15. So at 6, I'm at 15, so I've got another